Okay, I'm going to work just a few examples from the worksheet for tonight just to get you started, and as well, some of you guys are out today, so I want to do just a few with you. So this first little section here, we're trying to solve or find the intervals for x, which give us certain values of y. So for example, part A will be to find the values of x that give us positive y's. Part B will be y's that are equal to 0 or positive. Part C will be y's that are negative. Part D will be y's that are negative or equal to 0. So the first thing you want to do is you want to find your x-intercepts. You want to find all of your zeros for the function. Now you have to remember some of these may be imaginary, and we'll pretty much just find them, and then when we do our sign chart, we're pretty much just going to ignore them in terms of putting those values on the x-axis or the number line. So what I'm going to do first is I'm just going to basically know that I'm going to set each of these equal to 0. So I get x squared plus 4 equals 0. So then I would take the square root of a negative 4, and x would be a plus and minus 2i, because I'd be taking the square root of that. So plus and minus. Okay, so those are imaginary, so they're definitely not on our little number line. And then this one, I'm going to say 2x squared plus 3 is equal to 0. So I get 2x squared is equal to a negative 3. And again, you can see that you're going to end up taking the square root of a negative number, so also imaginary. So when I do my sign chart, you may feel like, okay, this is kind of unusual because I have no x-intercepts to put on my sign chart. So there's a couple of ways you could approach this. You could either think about the degree of the polynomial, which is going to be 4, because you have a quadratic prime factor and another quadratic prime factor. So that's going to give you a degree of 4. And an even polynomial with a positively coefficient is going to have in behavior where they both open up. So this polynomial function must be somewhere up here. So just to sort of verify, I am going to do a sign chart. I'm going to take a 0. And I'm going to plug in a 0 and kind of see what I get. So when I have 0, 0 squared is 0 plus 4 gives me a positive. 0 squared times 2 is going to give me 0 plus 3, another positive. So the entire interval of x's is positive. So when I start to answer A, B, C, D, A is going to be every value of x gives us a positive y. B, every value of x gives us a positive y or a y equal to 0. C and D are going to be the null set because there are no x's that give you y's that are equal to 0 or negative. So those are the null set. So that's kind of how you're going to approach this top section. Now, if you look at number 3 and you glance at this first one, it's something that does not factor, so you're going to have to use a quadratic formula. You may or may not get real solutions. You'll just kind of have to play around with that and figure out what's going on. So that's how you'll approach the top part. And then down at the bottom, I want to do number 7 with you to get you started on that one. So Picaro's packaging plant wishes to design boxes with a volume of not more than 100. So that means it has to be less than or equal to 100. It cannot be more than 100. So squares are to be cut from the corners of a 12-inch by 15-inch. So I'm going to kind of draw a little sketch here. So 12 by 15, and then squares, meaning all the dimensions are going to be the same for all 4 sides, obviously. So here I have x and x. Same thing here, same thing here. And the flaps are going to be folded up to make a box. So these are our little flaps, and they get folded up. So the base of your box is here. And then you cut out the corners, and then you fold the flaps up, and you basically could tape them, and that would create a box without a top. So what size squares should be cut from the cardboard? And here's the thing, I want my volume to be less than or equal to 100. So first I'll write the volume based on x. So remember that I need a length, a width, and then a height. So my length here is going to be 15 minus 2x. My width here is 12 minus 2x. And then, of course, I have the height of the little flap that gets folded is x. I'm going to stick that out front. So that's my function for volume. And I know that it can't be more than 100, so I'm basically going to say x, 15 minus 2x, 12 minus 2x, has to be less than or equal to 100. And then this is the part of the test you would have the graphing calculator on, so you would just subtract 100 over, basically shifting this function down by 100, but then you would look for the x-intercepts. Before I do that, though, I want to remind you that your dimensions must be positive. So each one of these, length, width, and height, have to be positive. So I'm going to take each one individually, and I'm going to establish what the domain should be. So the first one, x just has to be greater than 0. The next one, 15 minus 2x, has to be greater than 0. So when I solve for this, I get x must be less than 7.5. Because if I put in an x of 8, 2 times 8 is 16, 15 minus 16 would be a negative 1. I cannot have a negative dimension. So I'm just going to kind of circle the restrictions here. And then I'll do the last one, 12 minus 2x must also be greater than 0. And I get x must be less than 6. Now, if you are going to write out the domain of this function, you know that x has to be greater than 0. And then the highest value you can have, it appears to be 7.5. But what you want to do here, you need to make sure that it will actually satisfy all three of the dimension conditions. They have to be positive. So if I chose a value such as 7, for example, 7 would be fine here, but 7 won't be fine in this second one. So I'm going to always use the most restrictive dimension, which is going to be this third one right here. So x has to be less than 6 as well. So greater than 0, less than 6. Now, what I'm going to do is actually solve for the values of x that give me give me either 100 or less than 100. I'm going to solve for that and then kind of make sure I'm not violating the domain or the restrictions that we have here. So what I'm going to do in my calculator is, of course, graph this and find my x-intercepts, kind of set up my little number line. So go ahead in your graphing calculator, and we want to put in x times 15 minus 2x times 12 minus 2x, and then subtract the 100 over. So subtract 100. You're going to graph it. Now, I see I have some values here. I need to find these x-intercepts. So remember, you do that second calc 0, and I'm going to use what appears to be 0 and 1 as my bound. So I'm going to use 0 as a left bound, 1 as a right bound. So the first value is 0.69. Okay, so I'm going to write that down. You write that down on your sheet, and I'll kind of do 0.69. I'll show you in a minute what that looks like. And then I'm going to find this next one. It looks to be a little bit bigger than 4, so second calculate 0. And I'm going to use, let me just use 3, enter, 5, enter, enter. And that gives me 4.19. Okay, so that probably makes sense. That's going to be an irrational one. So 4.20 is what we'll go with. Okay, and then finally the third one looks like it's 5, 6, 7. Looks like it's between 8 and 9. So second calculate 0. And I'm just going to use 8 as a left bound, 9 as a right bound. And I think that'll work. It looks like it falls between the two. Enter. And I get 8.61. Okay, because it's not exactly 8, so it's going to be 8.61. So second, I'll just look at my data table so I can kind of see. So okay, yes, it does cross between 8 and 9, and it's going to be 8.61. So go back, and I just want to make sure you have all this down. So this is going to be right here, 8.61. Now, when we look at the graph, or if we do the sign chart, we can see that it's negative, then positive, negative, then positive. So this is going to be a negative interval, positive interval, negative interval, positive interval. Now, what are we looking for here? We're actually looking for when it's less than or equal to 0. So I'm looking for the negatives or equal to 0. So I'm going to kind of go ahead and make sure to note that these are solutions, and then any negative interval is also a solution. But I have to consider my domain. So my solution is anywhere from negative infinity to 0.69, but I can only start at this 0. So my first interval will be 0 to 0.69. Okay, and I am going to actually include the 0.69, but not the 0, because it has to be greater than 0. And it can include the 0.69 because that gives me exactly 100 for my volume. And then in union with, let's go to the next interval, so 4.20 to 8.61. So 4.20 is in my domain, but I have to stop at 6. So it's almost like you have to just truncate it right there. So I'm going to say 4.20, comma 6. And then the 4.20 is in my interval, but the 6 is not going, I mean, this 6 right here is not going to be, because I cannot have a 6 because it would violate that domain restriction right there. So this is actually my answer right here. So any x between 0 up to 0.69 inclusive, or any x from 4.20 inclusive up to 6 is going to give me a volume less than or equal to 100. So let me kind of just summarize this. What's going on here is you have a polynomial function. It's an inequality that you're solving using a sign chart. I'm just looking for where it's negative for this particular problem. And then I also have a domain restriction that I have to consider because each of my dimensions must be positive. So that summarizes kind of how we're going to approach those problems. And we, of course, will do some more in class tomorrow, and there's some more on the review.